see what we can do. So we're doing duality to get today. And remember contrapositive, that alpha implies beta, then if beta is not true, then alpha is not true. And notice we stuck in negations. Hey, GI, good to see you. And we switch the order there, right? And then so we can do an if and only if there. And when we do for alls, you can bring the negation in and it switches the for alls to an exist. Good morning, Samir. And De Morgan, right? You bring the negation in and you switch the and to an or, and double negation. So this is just sort of lemma's substitution, right? So if we so if you know that this string is true if and only if this string is true, then you can substitute that in whenever you need to. All right. So one of the things that we proved by cases last time was this statement down here. And one thing that we proved a number of times before that was this statement over here. This one is distributing the for all into an and this one is sort of distributing the exists into the or. And what we're going to show now is that if we know that this one's true, then we know that this one's true. And we're going to, good morning, Conrad. All right, so how are we going to do it? Suppose that we already proved this one, then we can just, let's start by, our goal, right, is to turn, right, what do we have to do? We have to turn this for all into it exists. We have to turn these ands into ors, right? So we just use the rules that we just kind of looked at, right? Let's start by, all we did is negated both sides. Now, here's a negation in front of a for all, so you can switch it to an exists. Here we have a negation in front of an and, so you can use the Morgan's law, right? So the for all becomes an exists, the negation comes in and the and becomes an or, right? And here we just we're substituting those things in. So, and now here we have an and in front of a negation in front of an and, so we can bring that in. And here we bring that negation in, the De Morgan's law, and here we have a negation in front of a for all, so we turn that into each of those into exists. Everybody kind of follow how we're just doing that? Good morning, Shanaz. I always can count on you.
Good morning, sir.
And to come a little late, which is both perfectly good. And then we got Ali. So we have our team here. I was like, it was lonely at 10 o'clock. All right, so what we're doing is doing proof by duality. So we suppose we assume this top statement right at the beginning, and now we're trying to switch all the for alls to exists and all the ands to ors, and we just do it by using the various rules that we have, right? And now we have, I guess we started by negating the outsides and bringing the negations in, right? So now we have the negations on the alphas, which we don't really want negations on the alphas. We don't want negations at all in our final statement. So we're going to rename this new thing, and I kind of overuse primes. Primes in general just mean it's a new variable name, but we know it's related to alpha. So I'm going to replace not alpha with alpha prime, and we're going to get that sentence down there, right? And then we can ask, well, is this what we wanted to prove? Remember, I wanted to prove something. Given this, I wanted to prove something else. And the thing is, it's right. It's what we wanted to prove, except, anybody notice the difference is that we got these primes in there when we don't really want them. All right, so this is what we did prove, and what we wanted to prove was the same statement without the primes. All right, any idea how we can deal with the fact that this is an alpha prime, right? Remember, this alpha prime is really a short form for right. Well, we can forget it. It's now some new new relation, right? So does one necessarily imply the other? And in general in the world, not necessarily, right? One model is going to fix some relation alpha prime and could fix some alphas to be completely different relations. And in one, right, this first one might be true or false, and this one might be true or false depending on various models, how you define alpha and alpha prime, right? So on the other hand, what did we say? What do we are claiming about this top line is we're claiming that it's valid. And if it's valid, then it's true in every model, right? That means it's true for every setting, no matter how you define alpha and beta, it's true. And that kind of, if it's true for all of them, then it should be, if it's true for any alpha, then it should be true for alpha prime, right? So we can say, well, now it's true for, right? Anyway, the point, if it's true for all of them, then we can replace the alpha primes with alphas and we're fine, right? So I guess here we had this proof that this is true for any alpha prime, any alpha and beta. And then what was our alpha prime, right? We define it like that. So that'll make this one true for any of those. And now if this is true for any alpha prime and beta prime, well, then it's true for alpha and beta, right? Does that make sense? And that gives us what we want to prove, right? And these two sentences, they look very different, but we're going to call them the duals of each other, all right? And if you remember from what we talked about last class, what are duals of each other? Good and evil are duals of each other. They're good morning, William. They're sort of different. They're sort of opposites, but they're, in some ways, they're the same. Some ways, if you learn about one, you learn about the other. And the other thing that's true about duals is if you take the dual of the dual, you get back to what you started, right? And so that's what we have in this example, is we're taking the duals. And what we're doing is, the dual is we're changing frogs to exists, and we're changing ands to ors, right? So that's what we're going to do. All right, so let's take any sentence alpha. Here's some examples, some sentence alpha. And when I talk about, remember that alpha is not actually part of our language. So we can't have alpha in our language. What we really are, our variables are P, or things like P and Q, right? So let's write down something all down to P's and Q's. And then George wants us to do everything syntactically. Syntactically mean we just treat it as a string of symbols, right? So put this string of symbols into your text editor and do global searches and replaces. All right, we're gonna globally swap. Whenever you see a for all, you're gonna put exists. Whenever you see exists, you put a for all. You just swap them. Whenever you see an and, you put an or. Wherever you see an or, you put an and, right? You swap them. In these sentences, right, they only contain these kind of things, right? All right, so we're gonna call what you get out of this the dual sentence, right? And dual, I'm gonna just put a little star up there. I think that's a common notation. In fact, the truth is, I don't think I've ever properly been taught about duals. I just had a gut sense from being a student for a million years that duality comes up. And I thought maybe we should teach it here. So I Googled it, and of course, Wikipedia came up with a page. And so what we're doing here comes from Wikipedia. All right, so here we take the dual. And one thing you'll notice, if you took the dual of the dual, you'll get your statement back again, right? Because we swapped for alls and exists. So if you did it again, swapped for alls exists again, you get back what you started, right?
Why, can I ask, why do we call it a dual and not a negation?
Well, there's a good question. Why would you want to call it a negation?
Is that not negation of the previous statement, or is that my mistake?
Well, you are being wise here. So there is certainly a negation feel to it. I guess you'll see that negations are going to come in here, but then you'll have to negate the P as well. It has a negation feel to it, and so some ways you can.
I see my mistake.
No, you're right. It's very negation-like, and it's the dual. All right. So but you're going to see. In fact, our first lemma looks very much like modus ponens. That if we were to take the negation, right? So what's here? What is not modus ponens? What it's called? Contrapositive. Contrapositive. If alpha gives me beta, then not beta gives me not alpha, right? So that is how you would use negations. And as Conrad sees, we're going to treat these duals kind of like negations, right? And so it's if the negation, if the dual is true, then that implies if the dual of beta is true, then the dual of alpha is true, right? So Conrad's definitely onto what we're doing. And of course, if that goes in both directions, then if alpha is true, if and only if beta is true, then one statement, the dual is true if and only if the dual is true, right? And so let's do a few examples. Here's one statement, and what is its dual? Its dual is that, right? We replace the for all with exists and with or, and here's another statement, and here's its dual, and we see if that one's true, if and only if that one's true, right? So that's kind of what we did on our last slides, right? We assumed we knew that this was a valid statement, and we concluded that this was a valid statement because we took the dual, right? Here's another example. We take the dual, and all right, so this says right? We take the dual of each, and if this implies that, then this implies that. You haven't seen this example yet, since I changed the order I'm doing things. This example, these are both valid, and we will do them in the next set of slides called free variable, scary free variable fail. That's what the next section of the slides is. And see here we have free variables, and free variables are scary, and that will be our next set of slides. Right, so here's another example. That's the dual of that, and what's the dual of that is this. And so we say, oh, well, this one turns out not to be valid, and this one here turns out to not be valid as well. Oh, actually, let's talk about George's textbook again. It mentions the word dual various places. It gives theorems, like it gives this theorem, and then it talks about the dual theorem. And I did a Google search through his book, since I had a text copy of it, and the word dual was never defined. So I don't know. It's just, he'll call this a theorem, and then he'll call this the dual theorem. All right, so here's another example. Say we got P. What's the dual of P? Well, the dual of P is just P, right? So what's the dual of Q is just Q, right? So this says if P implies Q, then Q implies P. Is that true? Does one follow from the other? Absolutely not, right? Just because P gives me Q, Q shouldn't give me P, right? And so that says something's wrong with this theorem, right? And what's wrong is that it doesn't say if this is true in your model, then this will be true in your model. It says if this is valid, i.e. it's true in every model, then this will be true in every model, right? And P implies Q is not true in every model, right? And hence, it's completely reasonable that Q implies P is not true in every model, and hence our theorem didn't fail, right? Does that make sense? All right, so here's another theorem. Suppose alpha has some variable P and some variable Q, and now we're talking about a particular model. All right, suppose you have some particular model, and alpha PQ is true. Then it follows that this weird thing, remember Conrad was wanting to take negations, but we're going to just take negations of everything. We're gonna take the dual, and then we're gonna take the negation of P inside of where we're doing inside of the brackets, and then we're gonna take the negation on the outside, and we didn't take, we just flipping negations everywhere. And the claim is that this thing is true in your model if and only if this is true in your model. All right. So we're going to prove this now by induction. Hopefully everybody remembers what induction is. And if you don't, it will warm us up for our next set of slides will all be about induction. But right now, all you have to do is, it's a little trickier even, we're doing induction on the length of the sentence. How many characters in your thing? So let's assume that we've already proved that this is true for anything that's short. And now we're going to try to prove that it's true for anything that's longer. All right. So what are we going to, or maybe you can think of, if that scares you, you can just think about this as proof by example. It turns out that it's a full proof, but if nothing else, you can have it roll over you like proof by example. So this is kind of our base case proof, right? If we just have if alpha p is simply p, right? We just have p, is our statement true, right? And what's the dual of p? The dual of p is just p, right? Because you replace exists with for alls and ands with ors, and we don't have any. So the dual of p is simply p. And then what's this whole thing? Well, you kind of you're sticking in two negations, right? And the two negations cancel each other, and you just get p back. And so this is just saying, right, this thing is true because if p's true, p's true. Right? Does that make sense? So it's just trying to work out what this is saying when alpha of p is simply p all by itself, and all it does is introduce two negations and they cancel. All right, so now let's have a case when we have some big sentence and the outside is a for all. All right, so alpha p is something like for all alpha, right? Something like this, for all x p, right? Then you take the dual, it replaces it with an exists. Then we're putting, what are we doing? We're putting a negation on the inside and a negation on the outside, right? That's kind of what we're doing. Within, we're putting a negation. On the outside, we're putting a negation. And sure enough, it turns back into for all, right? Does that make sense? And certainly the same is true for exists, right? And what about if we have an and here? Well, then the dual turns it into an or, and we slip our negation on the inside and we slip our negation on the outside, and we use De Morgan's, and we get back what we want, right? Does that make sense? Right? Is everybody kind of following that? Right. All right. So now, so this is just a repeat of our theorem. We're saying in any model that if you take the dual and you put a negation on the inside and a negation on the outside, then really you have the exact same statement, right? Which is kind of what Conrad was saying. He thought the dual was the same, and he forgot that, well, we're putting two negations in, but they're in different places. All right, so now we want to prove our statement, our first lemma, right? Which lemma says that if alpha is true, if alpha implies beta is valid, meaning it's true in any model, then beta dual implies alpha dual is true in any model. All right, and the proof is pretty straightforward, right? We're just going to bang, 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 and it will have it, right? So suppose that this is valid, meaning it's true in any model, right? So then what do we mean by true in every model? We're saying, well, in every model, in every universe, in every definition of P, every definition of Q, every definition of everything, this gives me that, right? And by lemma 3, then we can replace this with this, right? We can take the dual and put the negations in and out. Here we can take negations in and out, right? And then we can do contrapositive. Right here we have a negation on the outside, so we can do a contrapositive to get the implies in the other direction, right? And then, oh, good morning. Archon is bringing me tea. Isn't that nice? All right, so now this is the trick we did before. We're saying this statement is true for every P. If it's true for every P, then it's true for not P, right? If it's true for every possible P, one not possible P is not P. And so we get our statement. right? Does that make sense? Are people kind of following that? It's kind of what we did before. We have a negation on the outside, which switches the direction of the implies, and then the negation on the inside, which is right up against the variable. Well, if it's true for every variable, then it's true for, right, the negation of it. So it was good for me to study this on Wikipedia, because I had a sense that something like this was true, but like Conrad, I wasn't sure when I take the dual, do I replace? What do I do with negations? Do I replace negations? And somehow my implies, do I change the direction of implies? Maybe, it got a little complicated in more complicated examples, but here's the proof of something.
Sir, I have a question.
Yeah.
So you see the fourth line, you changed it to Q, P prime and Q prime. Like,
Yeah.
What reason did you give for that?
I just renamed it. I'm trying to get rid of, I got to get rid of that inner negation, right? Because I don't want it there. And so I just defined P prime to be the negation of P.
Then how does that change to P at the end?
All right, now I'm saying here, so you got this line then?
Yeah, I got that then.
All right,
yeah.
So now this is saying, this is true for every P prime. Every P prime you could possibly give me, this statement is true. In any model, for any P prime. Well, if it's true for any possible P prime, it should be true for P.
Okay.
Right? And that certainly is a trickier step. If something is true for any P, then it should be true for not P. Right? This first statement, it's if I'm saying this is valid, then I could define P to be right, it's telling me whether or not Bob is a father, or then I could replace it with, or it could telling me whether or not it's raining outside, right? So if P can be, is it raining outside? It could also be, P could be, is it not raining outside? Right? Certainly, if I'm saying this is true, is if P is my father, or if P says, is it raining outside, then it should also be true for, is it not raining outside? And so then that's kind of saying, well, if it's true for this, if P is it's raining outside, then not P is it's not raining outside. And it should be true for it's not raining outside. Right? Does that make sense?
Sir, from
Yes.
2 to 3, is it contrapositive?
GI, what were you saying?
From 2 to 3, is it contrapositive? Is that the
Yeah.
reason?
Yeah, I mean, how did we get from here to here? We just did contrapositive, right? Here, contrapositive.
Thank you.
Right, does that make sense? So now you know everything about duality that I know.